Welcome back to the Deep Dive, everybody. Today we're diving into a fascinating and, frankly, pretty concerning new area of research: the security of instruction-following retrievers. Now, if you're like most of our listeners, you're deeply interested in understanding what's happening at the cutting edge of machine learning, and you know that academic research is the place to look for that.
Absolutely. And this particular paper, it's titled Exploiting Instruction-Following Retrievers for Malicious Information Retrieval, and it's really starting to make some waves.
It is, and for good reason. We're seeing more and more adoption of these retrievers alongside LLMs, in everything from search engines to question answering systems and even content creation tools.
Right. They're essentially becoming the brains behind how we find and use information from these massive data sets. But this paper throws a wrench into the works. It raises a critical question. What happens when these increasingly powerful search tools fall into the wrong hands? What are the safety risks?
Yeah, and the researchers didn't just theorize about this, they actually put it to the test. They took 6 leading retrievers: NVMbed, LLM2Vec, DPR, Contriever, Promptriever, BGE, and ICL, and tested their ability to, satisfy what they call malicious queries, both directly and within a RAG framework.
Right. Retrieval-augmented generation. It's basically where you use a retriever to find information and then feed that to an LLM to, say, generate a response or complete a task.
And what they found was, I gotta say, pretty alarming. Many of these retrievers could select relevant, and I mean genuinely harmful, passages for over 50% of these malicious queries.
And that's the thing that really struck me. 50%, that's not just a small margin of error. It suggests that there's a fundamental gap in how we're thinking about the safety of these systems.
I mean, we spend so much time focusing on making sure LLMs themselves are safe, that they're aligned with our values, and they don't generate harmful content. But this research shows that the tools we're using to find the information for those LLMs, the retrievers, they could be a backdoor for all sorts of bad stuff.
It's like we built this amazing car with all the latest safety features, but then forgot to check if the steering wheel could be easily hacked.
Exactly. And it gets even scarier when you consider the fact that the researchers were able to exploit the instruction-following capabilities of these retrievers to surface very specific harmful information.
Yeah, the fine-grained queries, as they call them. It's not just about asking, how to build a bomb anymore. It's about crafting very precise queries that target the exact kind of harmful information someone might be looking for. They even gave an example, like instead of just a general bomb-making query, you could ask for a diagram showing a specific ignition sequence using readily available materials.
And they found that retrievers like Promptriever could pinpoint those exact passages with incredible accuracy.
Scary stuff. And then the final piece of this puzzle, the one that really makes you think, is what happens when you take those harmful retrieved passages and feed them to even a safety-aligned LLM like Llama 3. The paper shows that by providing this malicious context, those LLMs can actually be tricked into fulfilling harmful requests. It's like bypassing their safety measures completely.
So that's why we're here today on the Deep Dive. We want to dissect this paper, understand exactly what it's telling us, and explore what it means for the future of, responsible AI development.
Okay, so let's unpack this paper. First of all, it's really shining a light on a potential security risk in AI systems that, to be honest, hasn't gotten as much attention as, the LLMs themselves.
Yeah, everyone's worried about making sure the LLMs are safe and aligned, which is important. But this research shows that we can't forget about the tools we're using to feed those LLMs information. Because if the retriever itself is unsafe, the whole system becomes vulnerable.
Right. And the paper points out that while there has been some work on retriever safety, it's mostly been focused on what they call corpus poisoning.
Corpus poisoning.
Yeah, it's basically where someone tries to inject bad data into the training data sets or the indexes that the retrievers search. So the retriever ends up inadvertently pulling up harmful or misleading information.
Ah, I see. So this paper is looking at a different kind of threat, right? A more direct attack on the retriever itself.
Exactly. They're looking at whether you can exploit the retriever's ability to understand instructions to get it to basically deliberately find harmful content that's already out there. And they define malicious queries as those where, fulfilling the information need itself poses a significant risk.
And they use that bomb-making recipe as an example.
Right. So let's get into the experiments. The first set of experiments, they were trying to answer the question, can retrievers select harmful passages? And to do this, they built this special retrieval corpus. It had both harmful and benign passages.
Okay, how do they do that?
Well, they used an unaligned LLM to generate the harmful passages based on queries from AdVench, which is this, benchmark for testing how vulnerable models are to adversarial attacks. And then they used Lama, another LM, to make sure the generated passages were actually harmful.
Clever. So it was a mixed bag of safe and unsafe information, and then they tested those 6 retrievers against this corpus.
Right. They used a mix of traditional retrievers like DPR and Contriever, and the newer LLM-based retrievers like LLM2vec and Promptriever, and they tested them with both malicious queries from AdVench and benign queries from Trivia QA and natural questions.
So they had a way to compare how well they did at finding harmful versus safe information.
Exactly. And the results, they're in table 1 of the paper. It's pretty shocking. All 6 retrievers were able to find harmful passages.
Really? Even the ones based on safety-trained LLMs?
Yeah, even those. LLM2vec, for example, it had a top 1 accuracy of over 60% on the malicious queries. And what's even crazier is that for most of the retrievers, a harmful passage showed up in the top results over 90% of the time, even if it wasn't the most relevant.
Wow. So even if they weren't specifically looking for harmful content, they were still very likely to come across it.
Exactly. And it seems like the safety training in the base LLMs didn't really translate to safer retrieval behavior, which is a huge takeaway. It suggests that, just focusing on the LLM itself isn't enough. We need to think about the safety of the whole retrieval process.
Totally. So what about their second experiment?
Okay, so the second experiment, it was focused on the idea of fine-grained queries. They wanted to see if they could exploit the retrievers to find very specific harmful information.
Right, like those targeted bomb-making queries you were talking about earlier.
Yeah. So what they did was, for a set of 50 different NVMbed queries, they generated 10 different passages for each one, right? Each passage basically offered a slightly different way to carry out the malicious intent of the query.
So 10 variations on a theme.
Exactly. And then they used another LLM to create a really specific query for each of those query passage pairs. So the query was tailored to the exact content and details of that specific passage.
Okay, I'm starting to see where this is going. So they were testing whether the retrievers could, pinpoint the exact harmful passage out of 10 different options.
Right. And they used Promptriever for this experiment. And the results are in figure 2. It's pretty clear. Promptriever was able to find the correct passage on average at rank 2.09.
So basically it was almost always finding the exact harmful information they were looking for.
Yeah. Which means that the instruction following capabilities of these retrievers, they can be exploited to find very specific, very targeted, harmful content. It's pretty unsettling.
Okay, so let's talk about their final experiment. This is where they really connect it all together, right? They look at the impact of unsafe retrievers on LLM safety.
Right. So they took those NVMbed queries and had 3 different LLMs answer them, Llama 3, Mistral, and Gemma. But the key thing is they used NVMbed to retrieve up to 10 passages from their harmful and benign corpus. And they gave those passages to the LLMs as context before they generated their responses.
So they were basically testing whether feeding the LLMs harmful information from the retriever would make them more likely to generate harmful responses.
Exactly. And the results, they're in figure 3, and it's not good. All 3 LLMs, even Llama 3, which is supposed to be safety aligned, they became significantly more likely to generate harmful responses when they were given those harmful passages as context.
Wow. So even if you have a safe LLM, it can be compromised if it's getting bad information from the retriever.
It's like, you can teach someone to speak politely and respectfully, but if you then give them a script full of insults and hate speech, they're going to start saying those things, even if it goes against their nature.
It really highlights the importance of considering the entire information flow in these systems, not just the LLM itself. The retriever is a critical part of that flow.
Absolutely. So in their discussion section, the authors, they sum up their findings really well. They found that retrievers can select relevant harmful passages, that they can be exploited to find very specific harmful information, and that even safety-aligned LLMs can be made to generate harmful content if you feed them harmful information from a retriever.
And they emphasize the need for more research on retriever safety, which is great.
Yeah, this is clearly an emerging area of concern. And they also acknowledge a couple of limitations of their study.
Yeah, I noticed that. What were they?
Well, one thing they point out is that their corpus of harmful passages, it was generated by an LLM. And they say that getting real-world examples of harmful content for retrieval evaluation is like a big challenge. So their results might be a bit skewed because of that.
Makes sense. It's hard to collect a truly representative sample of everything bad out there.
Right. And the other limitation is that they mainly focused on overtly harmful queries, like the bomb-making stuff. They didn't really look at other types of sensitive or problematic information, like, personal data or hate speech.
So there's still a lot more to explore in this area.
Absolutely. I mean, this paper is just scratching the surface, really.
Yeah, it's really thought-provoking. So to understand this research better, I think it's helpful to take a step back and look at the history of information retrieval in machine learning.
Yeah, good point. I mean, these instruction following retrievers, they're actually a relatively new development compared to like traditional information retrieval systems or even dense retrieval models. For a long time, the focus was just on finding relevant information based on keywords or semantic similarity.
Right, and then we saw advancements in embedding techniques and benchmarks like MTB and BR, which really pushed the capabilities of these retrieval models forward. We started to see models that could understand the intent behind a query, not just the words themselves.
And instruction following is really an extension of that. It gives us even more control over the retrieval process, which is great for a lot of applications, but as this paper shows, it also creates new opportunities for misuse.
Right, it's like any powerful tool. It can be used for good or for bad.
Exactly. And this research really sits at the intersection of these advancements in retrieval and the whole field of AI safety.
It's like, initially, we were so focused on making sure the LLMs themselves were safe and aligned. But now, as we build more complex AI systems with multiple components, we're realizing that safety needs to be a concern at every level.
Absolutely. And it's a pattern we've seen before, right? In software development, in cybersecurity, whenever you have systems becoming more powerful and interconnected, new attack surfaces and vulnerabilities emerge. And that's what's happening here with these retrievers. They're becoming more sophisticated, more controllable, and that opens up new avenues for exploitation.
It's like we're constantly playing catch up with the security implications of our own advancements.
It's the never-ending story of technology, isn't it? But we have to keep learning and adapting.
Absolutely. Okay, so now for our novel notions segment, where we take the findings of this paper and brainstorm some potential future research directions.
Okay, so given how vulnerable these retrievers seem to be, one thing that immediately comes to mind is developing better safety mechanisms within the retrievers themselves.
Like building in safeguards that can prevent them from finding harmful information in the first place.
Exactly. We've seen some success with things like adversarial training for LLMs, where you train the model on a bunch of adversarial examples, basically trying to trick it into generating harmful content, and then you use that to make the model more robust.
So we could try something similar with retrievers. Train them to recognize and avoid harmful content.
Right. Expose them to these like adversarial queries that are designed to elicit harmful responses, and then use that to make them more resistant to those types of queries. The findings of this paper really suggest that this could be a fruitful area of research. If we could develop effective adversarial training techniques for retrievers, it would be a huge step towards making our RAG systems safer.
But, one potential challenge I see with this is defining what harmful actually means in the context of retrieval. It's not always black and white, right?
Yeah, that's a good point. Like, we wouldn't want to create retrievers that are so overly cautious that they end up filtering out perfectly benign information just because it's, sensitive or controversial. It's a delicate balance. Maybe a 4 out of 10 in terms of how likely it is we see a breakthrough in the next few years.
Yeah, I think that's a fair assessment. Okay, so for my novel notion, I was thinking about the idea of creating like context-aware retrievers that have dynamic safety filters.
Context-aware retrievers, what do you mean by that?
So instead of just relying on the query itself, the retriever would also analyze the content of the passages it's considering retrieving. It would look for signs of harmful content before actually presenting them to the user or feeding them to an LLM.
So it's like running the passages through a safety check before they even leave the retriever.
Exactly. And this safety filter, it could be dynamic, It could adjust its sensitivity based on things like the user's query history or the context of the application. So if someone has been searching for a lot of potentially dangerous information, the filter might be more strict.
That's an interesting idea. It would be like, having a security guard at the library who keeps an eye out for anyone trying to access restricted materials.
Precisely. And this approach, it seems like it could leverage all the advancements we're seeing in content analysis and anomaly detection. I mean, this paper shows that harmful content is out there and retrievers can find it. So having a system that can proactively detect and filter that content would be a huge improvement.
I like it. It's like a preemptive strike against harmful information. But One thing to consider is the computational overhead of this kind of real-time analysis.
Yeah.
If it slows down the retrieval process too much, it might not be practical.
Yeah, that's a valid concern. And also designing a filter that's both effective and doesn't flag too much benign content as harmful, that's going to be tricky. But it's definitely an area worth exploring, maybe a 3 out of 10 in terms of likelihood of widespread adoption in the next 5-7 years.
Yeah, I think that's reasonable. It's a technically challenging problem, but the potential benefits are significant.
Absolutely. Okay, well, those are our novel notions for today. Just remember, these are just speculative research ideas, right? Not fully formed solutions. But hopefully they'll spark some interesting discussions and maybe even inspire some new research.
Right, food for thought.
So to wrap up our deep dive today, the big takeaway from this paper is that the safety of instruction following retrievers is a critical issue that we need to be paying attention to. As these systems become more powerful and more widely adopted, we need to make sure that they're not being used to spread harmful information.
We can't just assume that because an LLM is safe, the whole system is safe. The retriever plays a crucial role in that, and we need to be thinking about security at every level.
Absolutely. And this paper is a great starting point for that conversation. We'll be sure to link to it in the show notes so you can check it out yourself.
And it raises a bigger question too, doesn't it? As we continue to build more and more complex AI systems, how do we ensure that all the components are safe and aligned, not just the LLMs?
That's a fantastic question to leave our listeners with. It's something we all need to be thinking about as we move forward in this exciting but also potentially dangerous field of AI. Thanks for joining us today in the Deep Dive. We'll be back next time with another fascinating paper.
Until then, keep learning and stay curious.
And stay safe out there in the digital world.
You bet.